Have you ever observed the transformation of matter? Every day, we see matter changing from one form to another. One of the most familiar example is water. When ice is heated, it melts into liquid water. On further heating, the liquid water turns into water vapor. At first glance, these changes appear dramatic. A hard solid becomes a flowing liquid, and the liquid eventually becomes an invisible gas. If we look deeper at the molecular level, we find that the interactions between water molecules change significantly in each state. In ice, the molecules are tightly arranged. In liquid water, they move more freely. In water vapor, they are far apart and move almost independently. However, despite these changes, the identity of the molecule remains exactly the same. Whether it exists as ice, liquid water, or water vapor, the molecule is still H2O. Changes in which the chemical identity of a substance remains unchanged are called physical changes. But not all transformations of matter are physical. Sometimes, substances undergo much deeper changes in which entirely new substances are formed. The identity of the substance changes. Such transformations are known as chemical reactions. Then how and why does matter transform chemically? We shall start with a simple question. Why does iron rust? Why does wood burn? How is food digested? How are medicines produced? All of these involve chemical reactions. A chemical reaction is a process in which one or more substances are transformed into one or more new substances. For example, when hydrogen combines with oxygen, water molecules are formed. Here, hydrogen and oxygen disappear as separate substances and water is formed. It is important to note that, in a chemical reaction, the identity of elements does not change, they just rearrange to form new substances. Since chemical reactions arise from the intrinsic nature of elements, they, like all natural processes, are governed by certain fundamental laws. Scientists noticed that all chemical reactions follow certain rules. These observations led to 4 important laws. These are: Law of conservation of mass, Law of definite proportions, Law of multiple proportions, and Law of reciprocal proportions. It is important to note that all these laws were established between 1789 to 1803, before the atomic theory proposed by Dalton in 1803. At this time, there was a very little understanding of atoms and other concepts such as valency and electrons. However, these laws were not based on theoretical assumptions, but on careful experimental observations. Therefore, they remain valid even today and known as the fundamental laws for the chemical reactions. Each law is a consequence of an attempt to solve a historical question. Therefore, we will discuss them one by one. First, coming to the law of conservation of mass. It was proposed by Antoine Lavoisier. Those days, the fundamental question was, when matter burns, where does it go? Does some of it disappear or become extinct completely? Before Lavoisier, many scientists believed in the phlogiston theory, which suggested that combustible substances released a mysterious substance during burning. Lavoisier carefully weighed reactants and the products in closed vessels after combustion. He found that the total mass before and after a reaction remained unchanged. Hence, he proposed an answer that became a fundamental law later. This law states that matter is neither created nor destroyed in a chemical reaction. They only change their form. Consider the neutralization reaction between sodium hydroxide and hydrochloric acid. Suppose we place a total of 1 gram of sodium hydroxide and hydrochloric acid in a closed reaction vessel. As the reaction proceeds, the amounts of NaOH and HCl gradually decrease, while the amounts of NaCl and H2O increase. However, at every instant during the reaction, the total mass of all the substances present inside the vessel remains 1 gram. This illustrates the law of conservation of mass. This showed that chemical reactions are rearrangements of matter, not creation or destruction of matter. In the next video we will discuss the other 3 laws of chemical reactions.